Thanks to everyone who's come along. Thanks for dialing. So here's my special screen. Thank you very much for dialing in. Thanks very much to the organisers who brought us together for the digital festival here. So my name is Dave Black. So I'm a digital consultant. There's actually a picture of me. I have longer hair now, thanks to lockdown. But that's me. That's what I looked like when I worked down in Leeds. So I work for Spark. Spark is a design and innovation consultancy. So our job is we provide innovation as a service to big organizations. We mostly work on very big strategic projects. And really that's kind of what I've come along to talk about today, is talk about the strategic view of design and how we do it. We've got about 70 plus people. So we've got lots of different categories of people. We've got some innovators, we've got strategists, service designers, we've got interface designers, researchers. I also have with me today one of my fellow Sparkies, Paul Bailey's with us. He's going to be my glamorous assistant today. So as we go through, if you've got questions, drop them into the Q&A function. You should find it on your Zoom. Drop them into the Q&A as we go. And either we can pick them up as we go along, or we'll pick them up at the end. And we can do a bit of Q&A when we're all done. So what am I here to talk about? So I'm here to talk about design patterns. So design patterns are a fundamental part of design. They're a fundamental part of how we approach design, how we do design. But they can help us to go beyond some of the constraints that happen within design thinking. I'm sure you're all familiar with design thinking. So I use design thinking all the time. I'm sure you probably do too. And I like design thinking. I genuinely do. But there are a few problems with it. Have you noticed this? I have. There's a few problems with design thinking. There are things that it doesn't do which we need it to be able to do. And actually, one of the things that I found over the last few years, in particular, working on really big projects, is ways to get around exactly these problems and these constraints that design thinking introduces. So I'm also here to talk about design. So the NHS is one of the big clients I've been deploying this with. Creativity, science, logic, depth, technology, prime numbers, and lots of things about exactly what design might look like in the future. Because the world's changing very quickly and design is changing very quickly. And I want to talk about how we can adapt better to that new future. So how did all this come about? Let me give you a little bit of background as to what's happening and how we came to these design patterns and how we came to this innovation view. So I got invited to join a team on the NHS to look at this as a brief. So the brief was, look at creating an any-to-any bookings, referrals, appointments, and advice and guidance management system. So basically what this is very straightforwardly to redesign the entire appointments and booking system for the whole NHS. So no pressure, right? Absolutely fine, no problem at all. It's really to look at probably the biggest system that the NHS, which is the second biggest organization in the world after the Chinese military, look at the biggest system that they have in place and to look at how we can improve it for doctors, clinicians, nurses, admin assistants, patients, everyone. So it's a huge project. There's an enormous thing built into this. And here's the catch. There's a kicker. You can't mess it up or people die. And this is deadly serious stuff. This is a really good project. It's a really interesting bit of work, but it's got risks attached to it. You can't afford to mess this up. So some of us might say, well, that's reasonably straightforward, isn't it? So all we have to do is use the design thinking approach, use the 5 stages of design thinking. We need to research the difficulties, we need to frame the problem, find out exactly what problems we're going to solve, think of some solutions, prototype them up, and then test them. And then go back again and iterate that, prototype and test, redo the solutions. Very easy stuff, right? So you apply that to this NHS project and just find that design thinking approach and run through it. Well, no, unfortunately. Actually, that doesn't work in this particular environment. And this is one of the first things I want to touch on. Design thinking doesn't work for everything. It doesn't work in every environment, and it doesn't work in this one. And here's why. The first problem is that the system is far too large to study. So you're talking about an organization which employs 1.7 million people and a further 300,000 contractors. You have 40,000 different systems all interconnected working together, made out of at least 500 different pieces of software. So studying everything and just doing user research becomes incredibly difficult in this environment. This is exacerbated by the fact that the system is really defined in its center. So right in the center is things like GP surgeries, hospital accident emergency departments. Things are very defined in these areas, which is they're connected very closely to one another. So GPs routinely refer patients into things like oncology clinics or rheumatology clinics or diabetes clinics. But out at the edges, which is things like ophthalmology, so that's Specsavers basically, things like private dentistry, things like physio clinics, it becomes incredibly ambiguous because there's a lot of private businesses working. There's a lot of places and businesses which are not really very well connected into the center. So the system becomes ambiguous. It's really hard even to see the size of the system. The third problem is the system is extremely fragmented. There's a lot of different things going on, a lot of different things at different times, and they're not connected together. It's broken up. There are silos and there are organizational boundaries. So it's really hard to get a research piece which tells you that you're looking at the right thing. So studying a representative part is basically impossible. So when you're doing user research, I'm sure you'll all be familiar with this, you really want to be able to go and talk to users, which in this case is patients and clinicians, and you want to be able to talk to these people and have a good idea that the group that you're talking to are representative of the whole. You can't do it in this case because of the ambiguousness of the system at its edges. And the last thing, the other reason is the total number of problems is incredibly large. There are a huge number of problems in the NHS. I say this, I love the NHS. I say this to all the affection in the world. Because of the size of the organization, because of the way they're set up, the number of problems that patients experience is gigantic. So what did we do? So you can't use a standard design thinking approach. We established that very quickly. So what we did was we sliced up the system and started to study what we could get hold of, but also taking into account what we couldn't get hold of, what we couldn't see. So we accepted that we couldn't study the entire system. And what we ended up with is something looking a little bit like this. So you might have seen this before. This is called a Sankey diagram. So what we have at the right-hand side is a list of the big problems that we found. So there are about 250 of them in this particular version. The total number of problems was over a couple of thousand. But the total number on this particular diagram, the big ones aggregated together are 250. And what you find very quickly is that they have parent problems. So as you head towards the left on the diagram, if you look at the way it works together, the problems on the right-hand side have parent problems. So the problems around some of the technology, around things like workflows and things the way that referrals work, have parent problems like paper letters are being used as a workaround, or the patient doesn't know what's going on, or patients have accessibility needs which are not being met. And the further left you go, the bigger the groups of problems you find are. And what we realized was this gives you two things. First thing it does is it lets you see, if you want to solve one of the problems on the right, it lets you see which parent problem or grandparent problem you need to solve to make that happen. And the other thing is that it tells you what other problems you'll solve in doing so. So if we take, for example, number 8 there, no easy way for patients to interact with referrals. If we solve that problem, a big bucket of problems on the right-hand side all get solved at the same time. The other thing we got was this. This is a huge model of all the patient needs. And we got an enormous amount of data out around the patient needs. So what we ended up with was lots and lots and lots and lots and lots and lots of problems. And we understand the problems really well. We understand what they are, and we understand the huge scale of them. But it's too much. It's far too much. It's too much to tackle using design thinking. There isn't a way to parse those into simple problem statements which you can then tackle. So what we realized was we couldn't do a couple of things. We couldn't look at the whole thing, but we also couldn't look at one part. So the whole thing was too big and the one parts were not representative. So what could we do? How can we get around that? And this is where we started to work on design patterns. We realized that there were patterns in the data. So the patterns in the data were around particular topics. We started to see particular behaviors, which we saw time and time again. We started to see particular artifacts in the system. So we realized there were these patterns. And what we realized was that this pattern existed. So this is a design pattern. Specifically, this is a service pattern. So those 8 circles along the top are the abstract stages that every appointment within the NHS goes through. So firstly, what happens is a need is identified, care is requested, somebody then assesses the need and says, what kind of care does this patient need? The care gets planned, which is to say we plan out exactly what care we're going to apply. We arrange the care, so we give it a date and a time and a place. We wait to receive the care. We're all familiar with the waiting lists. And then we provide the care, we receive and provide the care. Now, this is very abstract. So in some cases, this process might take 8 months because things like waiting for diabetes treatment or waiting for cancer treatment can take a really long time. Sometimes the wait to receive care stage is months and months. On the other hand, sometimes this abstract set of service patterns, this can all be done in 15 seconds and acts in an emergency. Sometimes the arranging care and the planning care is a phone call to an operating theatre to say, I've got a person with a stab wound coming up, can you get them sorted, please? So it's very abstract, but it applies across the environment. The other thing is that it's also abstract in terms of the user. So this isn't tied to one user. So clinicians see these stages differently to patients see them. So for a clinician, assessing need is one thing, but for a patient, having their need assessed is a different thing. Similarly, waiting to receive care. So for a clinician, it's all about managing waiting lists, it's all about managing work rotas, it's about managing clinics. For a patient, it's around waiting and fretting and wondering what's going on. So the stages are the same for every user, but they're experienced in different ways. And this gives us quite a powerful tool as we go through. So these different colored dots are the different actors. So it's telling us what's going on. So there's a lot of really interesting stuff happening in this. And the service pattern becomes quite powerful. And we see it repeated over and over across the entire estate. Everywhere we looked in the NHS, we found this pattern. We saw it in hospitals, we saw it in GP surgeries, we saw it in physio surgeries, we saw it in things like mental health settings. And it repeats time and time again, and it becomes sort of ubiquitous, which is a huge red flag straight away. This is a big problem. Seeing something like this repeating time and time again, it's a wonderful moment, but it's a big red flag. I'll explain why. You have to be sure. It's not enough to have a hunch in this space. Remember that some people can die if you get this wrong. So you've got to be sure. And the only way to do that is to question yourself and question your own approach. Let me show you why. Some of you will probably recognize these. These are prime numbers. You might know what prime numbers are. Some prime numbers are numbers which are only divisible by themselves and one. This is a list of the first few prime numbers. You'll notice that 1 is not a prime number, interestingly enough. And the interesting thing about the prime numbers is if you look at them there, you can't really see a pattern. You can't really see a pattern within them. So how can you map them? How can you analyze them? How can you look at them? So there is a way to do it. So here's the thing. This is called an Ulam spiral. So if you take the prime numbers and you map them on a spiral, spiraling out from the center, so that dot in the very center is 2, and then there's 3, and then there's 5, and then there's 7, and so on and so on. These patterns start to form. You can probably see these diagonal lines. It's interesting, isn't it? So you can see the things in this thing called the Ulam spiral. You can see prime numbers which apparently have no pattern. As you spiral outwards, if you map them this way, you get patterns. Now, the reason that this is a red flag is because there actually aren't patterns in prime numbers. The pattern is actually in the mapping method. So the reason that this pattern exists and develops is because prime numbers necessarily, all the prime numbers which are greater than 2 are all odd numbers, because otherwise they'd be divisible by 2. So the spaces that you're seeing, these diagonal line spaces, are actually lines of even numbers that you're skipping over. So the pattern is not actually in the prime numbers, the pattern is actually in the mapping method. So when we looked at the service patterns for NHS, we needed to be very, very sure that it wasn't our mapping method that wasn't producing that pattern. As an aside, if anybody can find a pattern in the prime numbers, you have a number of major prizes waiting for you. Not a Nobel Prize, there's no Nobel Prize for mathematics, it's just the Fields Medal. But you'll win lots and lots and lots of prizes if you can find a pattern in the prime numbers, because there is no known pattern. The pattern in this case is in the mapping method. So the way to make sure the pattern is real and not be an artifact of our mapping method is to find the origin of the pattern. And we did find it. We did quite a lot of research. We talked to a lot of different people, and we found out where the pattern comes from. So it comes from these things called commissioning guidelines. So they're the bedrock of the NHS. The NHS commissions services from private and public companies. So they commission them and contract them to provide particular services, like physio service or dentistry services or GP services. So everywhere these guidelines exist, we're going to see this pattern, because the pattern is built into the guidelines. The idea of the appointment, the idea of waiting lists, the idea is all built into the commissioning guidelines. So in theory, what it gives us a predictive power. So everywhere the guidelines exist, we should see the same patterns. And we did. And we tried lots and lots of places. And everywhere that the guidelines existed, we started to see these service patterns. To use a good analogy, the reason that we do this, imagine you're a scientist and you want to know hydrogen and oxygen bind together to create water. So you don't go all over the world and test every single hydrogen and oxygen molecule to see whether atom to see whether they bind together to create water. Because once you understand why they bond together to make water, you don't need to go any further anymore. So that's what we're doing with these service patterns. Once we understand why the service pattern exists and why those behaviors exist for the clinicians and for the patients, we don't have to keep researching. We don't have to keep repeating the same research over and over in different settings, because we know that everywhere that the source exists and everywhere the root cause exists, we will see the same behaviors and see the same patterns. So what's the value of patterns? Well, the pattern is reproducible. You can use them to build very complex systems. The systems that we're building in this case are very, very complicated. They're very large systems. And we need a set of simple rules that they spring from. And the reason you use that is twofold. Partly because you need the thing to be actually buildable and kind of abstract in an abstract sense. You actually need to produce something useful. But the other thing is you need to be able to change the system at some point in the future. So it allows us to change bottom up. So if we have that abstract service pattern, if at some point in the future we say the service pattern is going to change, something about the service pattern, one of these steps is going to change, we're going to add an extra step. Because the system is built in the service patterns, when we change the service pattern, the whole system will change. It propagates across the system. So where does this lead us? Well, the answer is that it leads us to places beyond design thinking. So we've stepped now past design thinking. So we've gone beyond this stage of simply making local observations about problems. So design thinking is based on observation, what creativity is, but it's based on observation of local problems. And what we've done is we've found a way to find problems which we haven't seen so far, and to know that problems will exist in a particular area because we understand their source. So instead of having to see the problem directly and actually study it directly, we can now see know that that problem will exist somewhere else. So let me show you the problem with design thinking. And again, I say this with affection because I like design thinking, I really do. It's been a great tool, but it has a problem. So there's a slightly odd thing that we do during design thinking. So what we do is we build a product, we test and use it, and then we try and learn from testing and using it. And we use that learning to produce another product. And then we test and use that one and learn from it, and so on and so forth. And what we end up with is we end up with a chain of products, which we're constantly producing. What we actually need is we need a system where it's not the chain of products which is the underlying factor, it's a chain of evidence and understanding. So what we need to have is we need to have a chain of experiments which produce evidence. So instead of using products to produce new products, we use evidence and experimentation to produce products. So at some point during the process, you have a decision-making process which says, we now know enough to build a product. Let me sum this up. So the problem with design thinking is that it gets its evidence from the products. And what we should be doing is building the products based on the evidence. So you need to get evidence from somewhere. And you need to get from somewhere other than just old products, because otherwise you're constantly studying old products which you know are out of date and actually you plan to replace them. So how do we get the evidence? Well, the first thing we need to do is we need to test hypothesis. So we need to have a hunch about how things should be. And in the case of BRAM, the service pattern started to give us that hunch because we were able to work on that with that service pattern and build 2B models which had a predictive power, because we knew that everywhere that the current commissioning guidelines existed, we could build these 2B models. So you need to test a hypothesis, you need to have a rigorous method. So again, it's not about just finger in the air about what you feel should be right, you need to have a database method for this. That means you need to create data, and as with water, we need to lead to why something happens and not how and what is happening. We really need to understand what's going on in the background. So this is the framework that Spark used. So we do experimentation. So instead of doing technology alphas or something like that, we actually use an experimentation framework. So we have an idea. The idea leads to a hunch, that's your hypothesis. We then do an experiment which produces data, and then based on that data, we can then deliver a product and launch it. So the advantages of experiments are manifold. The first thing they give us is they give us an increasing quality of evidence and decisions. So over time, the amount of understanding you have of your patients in this case, or customers in some other cases, and of the products that they use is gradually increasing, because you're not losing previous learnings by discarding old products. You have a constantly increasing base of evidence and understanding. The value of the product portfolio increases because, again, it's based on an increased understanding, and their risk is reduced because you're constantly, you have a group of people and you have groups of decision makers within your business, within your organization, who are able to understand what's going on. And they're not just working on this product right now, they've worked on lots of other products and they know what the evidence looks like. Gives you a primary data source for analysis. Again, going forwards, if you want to make decisions strategically, you need to have that data analysis. And the last thing is it gives you new ways to do product development. So here's the solution. What you need is an increasing quality of evidence and decisions. You need that chain. Instead of a chain of products, it's a chain of evidence and understanding. And that's exactly what we're doing with the design patterns with this new approach. So it might look familiar. Something a little bit interesting in this. So something really interesting starts to happen, which is it becomes an evolutionary approach. So instead of building one thing, standing it up, running it for a while, and then waiting until it becomes obsolete and replacing it, what you end up with is you end up with an evolutionary approach. So there's a little picture of evolution here. So in a sense, the underlying data is your DNA. So evolution comes from DNA, we all know this. And there are a number of key similarities here. The data is the DNA, and what happens is, as you go along, as the data accumulates and as the data changes, organisms appear spontaneously because it becomes the right time and the environment is right for that organism to appear. Now you start with simple things. If we look at the left-hand side there, evolution started with single-celled animals, the simplest possible form of life. And as time went by, those single-celled animals then turned into other things. So they turned into jellyfish in this case. Then we had dinosaurs. And then you have another interesting parallel, which is sometimes catastrophes happen. Sometimes the environment changes very quickly in a way that's out of control. Now, this system is responsive to that. This system allows you, because you're basing it not on products, but on data, the data can then change to fit the environment. You can understand the new environment and the new constraints, and something new can appear. So in this case, it's kangaroos, gorillas, and tennis players, apparently. Tennis players being the highest point of evolution, as you can see. But as time goes by, what you end up with is you end up with an evolving base of information and understanding, which leads to these products which are fit for their environment. They're fit for a changing environment. Instead of being developed at a single point in time and then made static, they can change over time. So why? What's the point in all of this? So again, we need systems which are resilient. So I don't know if you've noticed, but we've had quite a lot of big changes over the last year. And a lot of systems have been very heavily challenged. Now, I'm not just talking about systems like, as in computer systems. We're talking about systems like the systems of how we do housing, how we do commuting, how we do travel, how we eat out. All of these systems have been heavily challenged by COVID, and change is required. And designers should be capable of looking at these business problems just as easily as we look at technology and software problems. So we need systems which are resilient and can stand knocks. We need systems which respond to changing conditions. When conditions change, when the environment changes, we need to be able the systems to evolve and to change along with those conditions. The continuous improvement for the system has to be built into it. Instead of having a system where the product is just a thing which we then replace, the products actually have to be able to change themselves. Actually, the products and the environment and the teams need to be able to change. And the last thing is the products have to be based on reality. So reality is messy. Reality is not clean. We all know this. We design wonderful products in the confines of safe environments. We design these lovely, lovely products, and then we launch them and suddenly weird things happen. Users do strange things, patients do strange things, and the systems get used in odd ways and strange things happen. That's because reality is not a tidy, simple, straightforward thing. The other reason is that we need to be sure. Again, we need to be sure of what we're doing. And there are a number of reasons why we need to be sure. The first reason is that the future is going to belong to systems which can adapt to a world which changes rapidly. Now, in order to be able to do that, It's not enough to kind of guess. So evolution doesn't guess. Evolution responds to the environment and produces a survivable organism for that particular point in time. The other reason, and this is a really important one, I'm going to dwell on this for a couple of minutes. Does anyone here like smartphones? I love smartphones. I love my smartphone. I have one on my desk right now. I think they're wonderful things. I'm still enthralled by them, even though they've been around for a while. But there's something very interesting about smartphones, isn't there? Which is they haven't changed very much in the last little while. The basic formulation of a smartphone, so some things change. So sometimes we get notches in the bezel. Sometimes we get buttons which are on screen. Sometimes, as you can see from this example on screen, the buttons are actually on the outside. But they haven't substantially changed, probably in about 10 years. Now, there's a good reason for that. It's actually not just because of profit and because it makes them cheaper to manufacture. It's actually just because the smartphone as it stands now is a pretty good response to the specific challenges and the problems that it was intended to solve. We don't really need to go a lot further than we've gone so far. We don't really need to reinvent smartphones. Now, if the environment changes, if something in the environment changes, yeah, we might need to change them radically. Actually, the changing environment and the emergence of the internet is why the smartphones appeared in the first place. If you look at the difference between a Nokia 3310 and an iPhone, the reason that the one evolved into the other, they didn't base the iPhone on the Nokia, the needs evolved was because of the evolving needs, and the environment changed, and the need for mobile internet in particular became apparent. And that's why we now have these things. But here's the thing. Quite a lot of those problems, they're actually not very difficult problems. They're actually, and they're also not very, very dangerous problems. They're actually reasonably easy to solve in technological terms. And we've actually solved, I think, quite a lot of the easier problems. So quite a lot of the problems where we just want to digitize something which exists already, like an encyclopedia, or a book, or a television, most of those problems have now been solved. And what we're actually left with now is we're left with a body of very, very scary, difficult problems. Now, it's not that nobody knows these problems exist. We've all known for a long time that they exist. This NHS project, BRAM, is a good example of this. Anyone who has had an appointment with their doctor or had an appointment where they had a waiting list will know that there are problems with appointments, and will know that there are problems with waiting lists, and know that there are problems with the way that care is delivered. But there's a good reason why those problems haven't been solved to date. It's because they're very, very difficult problems. Now, to solve those problems, in the case that we're talking about here, for example, standard design thinking actually just doesn't cut it. We actually need to step beyond design thinking and do something better and more robust. Because again, a lot of the problems that we're dealing with have very serious consequences. And again, I'm not just talking about the NHS here. Let's talk about things like benefits, universal basic income. Let's talk about the way that COVID has impacted us, the way that pandemics are handled. Let's talk about fundamental parts of society like poverty, things like identity, things like the way that we share things and the way we use society together. These have serious consequences because people can become excluded, people can become unable to engage with the systems that we build, and ultimately the dangers involved are really significant. The other thing that we need to be able to do to solve these really difficult problems is we need to be confident. We need ways to be confident. Being sure leads to confidence. Having data leads to confidence. If we understand really thoroughly, and this goes back to our water analogy, if we know why things happen rather than just what is happening, then that allows us to be far more confident in our decision makings. And we do need to be confident. To solve these really difficult problems, we need to have strong ideas. And strong ideas come from confidence and surety and knowing that we're doing the right thing at the right time for the right people. So what do we need? We don't just need new products. We actually need completely new design methods. We need new ways to tackle these really big, scary problems. And crucially, we need a way to approach them that makes sure they stay solved. Again, if I had one big criticism of design thinking, it's that the problem never stays solved because new problems appear and ultimately the thing that you've built becomes obsolete. It becomes a thing that doesn't work in that environment anymore. What we really need to do is to build systems and have design methodologies which give us the information, the data that we need so that the problem stays solved even when the environment changes. And that all starts with patterns. It all starts with patterns at the bottom level. At the very, very bottom of all of this is the simple recognition that there are patterns in what we do. And whether you use even the most basic type of design and the most basic software, and whether you're working on something as little as an app on a phone or something as humongous as an entire change for the government, it's all based on finding those patterns and enabling the ability to be able to see why the patterns exist, where the patterns come from, and what change is required to build something which is going to last for the future. So that's it. That's half an hour. As I say, my name's Dave Black. If you want to talk to me on email, you can grab me at that email address. You can also chat to the whole of Spark if you want to. And I'm obliged by my contract. Apparently, I have to tell everyone that I am I'm hiring. So we're hiring a number of different roles. We've got service designers, particularly, we're looking for at the moment. We're growing very rapidly. We've done quite well in the pandemic. We've got a lot of work with NHS. So if you're interested, drop me an email, or you can get hold of me on LinkedIn. I'll be very happy to talk to anybody about any of the stuff we've talked to. And thank you very much for listening. Thank you very much indeed. I've really enjoyed it. I will hand over to Paul, my glamorous assistant, if there's any Q&As, Paul.
Yeah, so I'm going to kick things off. So if you've got a question for Dave, feel free to submit it in the Q&A. But I guess from my perspective, I'm quite curious about how do you kind of know when you might be spotting a pattern? So, you know, you must be looking for these things all the time now. Have you got any hints or tips on when you have an inkling that something might be becoming a pattern?
This is an interesting question. I think there's a bit of a kind of misconception, I think, which exists within design. And it's actually a misconception that I wrestled with for a really long time. I used to work with banks. If anyone's wondering if you'd ever take a job with a bank, worry no longer. I worked with banks. I didn't really enjoy working with the banks, but I found something really strange when I was doing user research with them. So we were researching things like the ways people use things like credit cards and loans. And the strange thing was actually that we saw the same behaviors time and time again, everywhere we looked, so much so that we could actually create these behavioral personas. So I'm sure that a lot of us designers here are familiar with personas. We actually understand personas pretty well. But it didn't sit well with me. And I wondered why I was seeing the same behavior time and time again, because in my view and in my mind, human beings are incredibly complex. Human beings are very strange things who do very strange things at strange times and do things in strange ways. So the idea that they should have regular behaviors which cropped up over and over again really didn't make any sense to me. So I sat down, I had a beer with a brilliant user researcher, a guy called Paul Jervis Heath. He works for a company called Modern Human down in Cambridge. And I sat down with him and I laid out my problem. I said, I don't understand why I see the same patterns time and time again, the pattern of behavior. It doesn't make any sense. And he said, no. And he said, you've got it back to front. You've got the wrong end of the stick here. He said, the systems that you're looking at are fundamentally rule-based. So what you actually have is, you've got a system where a user has a very limited number of possible moves from their current position. It's a bit like chess, only it's not that complicated. It's more like noughts and crosses. So let's take, for example, in the banking environment, you've got a position where a customer is thinking about buying a credit card. Well, what can they do? Well, they can go to a comparison website and find out about credit cards. They can go to your own bank's website and find out what you offer. They can go and research things like APRs and AERs and find out what the numbers mean. And then after that, what have they got? Well, they can get a quote, or they could go and use a calculator, or they could apply for a credit card. So the number of moves is very limited. It's not actually an open system in which people can do whatever they want. So actually, what you're looking at is rule-based systems, and the behaviors that you're actually seeing are game-playing behaviors. What you're actually seeing is users trying to find the best moves to get towards an outcome which is suitable for them, which is, to get the credit card with the right credit limit, for example. That's their outcome, that's their end state. So when you do the research and when you actually look at the environment, you can actually spot the rules and can start seeing the game behaviors. So you see people trying to game the system. You see people trying to get around restrictions. So there's a number of different things that happen. But ultimately, the patterns always emanate from those rules and from those game playing behaviors. And everywhere that there is a system which is fundamentally rule-based, you will eventually see patterns. Now, exactly where those patterns come from and what rules they are that govern the patterns varies hugely from system to system. So again, in those banking systems, it's actually the range of different options that are available to them that produce these patterns. In other environments, for example, in public services, there are different things which can produce the patterns. Ultimately, though, you do see the pattern because it's rule-based behavior. Does that kind of make sense?
It does, yeah. Yeah, and it's really fascinating because I think once you start thinking about it in that way, it's kind of, you can understand how it works from a service perspective, but when you start applying it even more broadly than that, then it's like, wow, okay. I'd imagine you start looking for these things everywhere.
I think there's something else that's built into it, which is there is a temptation for designers to imagine that users are somehow failing when they don't use the system, inverted commas, properly, which is the idea that there was a supposed outcome that they were supposed to head towards, but somehow they didn't. Actually, in most cases, when you study it, you find that the users played the game exactly the way that they wanted to. And either they couldn't make the moves that they wanted to get to the outcome that they wanted, or fundamentally they couldn't figure it out. They couldn't figure out what the rules were. And most people are pretty smart. They are usually able to play the game if you present them with the rules and make them really clear. But there's a really strong temptation amongst designers, and I won't lie, I made this mistake myself, to think that people are silly or foolish because they're not using the system properly. Well, usually it's the system's fault, and usually it's the designer's fault.
Sorry, I lost you on the end of that bit, Dave.
Sorry, yeah, sorry. Usually it's not the user's fault at all. It's not their failure to follow the rules. It's actually a fundamental problem with the system that they're not able to see the rules and not able to follow them. That's all it is.
So it's a really great example that you've shared with us today. I really appreciate it. We haven't got any other questions at this point. So is there anything else that you want to kind of say in terms of us wrapping things up?
No, I know it's the end of the day. I know it's a nice sort of moment to the end of the day on. I just say thanks very much to everyone for listening. I'm not saying that this is the future of design. I'm saying this is just something that we've found, and I hope that someone will find it useful, and that maybe some of the things we talked about can be productive in some of your own work. If you have any questions, as I say, you can catch me on LinkedIn or you can catch me on email, and you can go to the Spark website as well. So thank you very much for listening, and thank you for your time.
Thanks, Dave. Really great talk. Really, it's not the first time I've seen it, but every time it makes me think about something completely new. So thanks a lot for preparing and sharing it with us. Really appreciate it.
Thank you very much.